Hi, Integrated Math 1. Welcome to the next topic. We're still on Module 2, but now we're on Topic 4, and we're just going to do the first part of Lesson 1. We're not going to get all the way through it today. We're just going to do Activity 1.1. So we're on Lesson 2.4.1a. Yeah, that's how that's going. So we're starting off on page M2-250 on our book. And we're going to be looking at calculating the distance on a coordinate plane. How do you find the distance between 2 points on a coordinate plane? So we're going to analyze quadrilaterals that lie on a coordinate plane. We're going to classify them by their properties, right? We were just talking about that in our getting started activity. What makes a rectangle a rectangle? What makes a square a square? What makes a parallelogram, a rhombus, all that good stuff. And we're going to play with that a little bit more today, only on a coordinate plane. So to get us started, taking a look at our lovely quadrilateral A, B, C, D here on our coordinate plane. Can you classify the quadrilateral for me? Tell me, what kind of a quadrilateral is it? Parallelogram, square, rhombus, trapezoid? What are we looking at here? Give me the most specific name you can come up with for this. And make sure you justify your reasoning. Tell me how you know it is what it is. Go ahead and hit pause, write down your answer and your justification, and then hit play when you're ready to check your work. So I don't know about you guys, but this looks like a square to me. So I did say that quadrilateral ABCD is a square, but we needed to justify that, right? So I noticed a few things. Let me grab my pen here. I noticed that if I counted the lengths of the sides, if I was like 1, 2, 3, 4, 5, 6, that guy had a side length of 6, 1, 2, 3, 4, 5, 6. And so did that one. 1, 2, 3, 4, 5, 6. Yep. Looks like we've all got all these sides of a side length of 6. But also, that's not enough, right? We said that in order to be a square, you've got to have 4 congruent angles, 4 right angles. Well, check it out. I've got horizontal lines and vertical lines. And we know that horizontal and vertical lines do, in fact, make right angles. And so sure enough, I've got a whole bunch of right angles here. So because its sides are horizontal and vertical line segments, they are perpendicular, so the figure does have 4 right angles. And again, using that number line, we can just count and we're like, oh, look, they're all the same length. So using the number line on the axes here, we can determine the distance between those vertices, and we can conclude that all the side lengths are congruent, right? All of our side lengths were 6. So that was nice. That's a square. Yay. But what about this one? Determine whether quadrilateral EFGH can be classified as a parallelogram and justify your reasoning. I'm going to give you a hint. See if you can figure out the slopes of your sides. That's my hint to you, all right? Go ahead and hit pause. Find all these slopes and tell me whether or not you can say, yes, that's a parallelogram. And then hit play when you're ready to keep the discussion going. All right, how you doing? Did you find the slopes? Like I looked at this one first, EF, and I was like, okay, we're going down, so it's a negative slope. And I could actually count how many, right? From E, I could be like, okay, I'm going 1, 2, 3 units down. Oops, sorry about that. 3 units down. So that means my slope is a -3 over, right? Rise over run. And I had to go over 1, 2, 3, 4. So I went over 4. So my rise was a -3 and my run was 4. So my slope for EF is -3/4. And then I was like, well, but in order to be a parallelogram, they have to have the same slope, right? Parallel lines have the same slope. So I thought, all right, well, EF has to have the same slope as GH. So I started here at H and I was like, okay, well, I went down 1, 2, 3. So I went down 3 and I ran 4, 1, 2, 3, 4. Oh, so it looks like my slope on GH is also negative 3/4. That's a good sign, right? If they have the same slope, those two sides are parallel. But in order to be a parallelogram, we do need to make sure that both sets of sides have parallel sides. So let's find the slope for the other guys. So if I start off, so I know that side EF and GH, those guys are parallel, they have the same slope. But let's check these other guys. Let's check HE. It looks like I have to rise over run, right? Rise over run. So I have to rise 1, 2, 3. I have to rise 4 and then run 3. So I went up 4 and over 3. So it looks like the slope of HE is 4/3. And we want it to match this other guy down here. We do want it to match FG. So let's see what we can do here. It looks like I have to go up 4. So from G to F, I got to go up 4. 1, 2, 3, 4. And then run 3. 1, 2, 3. So I'm going up 4 and I ran 3. So my slope for GF or FG is also 4/3. That's great, right? Because that means that side HE and side FG are also parallel. They also have the same slope. So because I have two sets of parallel sides, sure enough, quadrilateral EFGH is a parallelogram. That's great. So I know it's a parallelogram. Can we take it further? Can we take it further? Let's take it further. Can you say it's a rectangle? Can we classify it as a rectangle? What does it mean to be a rectangle? And maybe the slopes can help you with that too. Go ahead and hit pause. Don't forget to just tell me whether or not it can be a the quadrilateral can be a rectangle, and don't forget to tell me why to justify your reasoning. So go ahead and hit pause, take care of that, hit play to keep this party going. How you doing? So I was looking at the slopes, and here's why. Because if it's a rectangle, that means I should have 4 right angles, doesn't it? We talked about that a little bit before when we were talking about a square. A rectangle is 4 right angles. I need to know that these lines are perpendicular. So we already found the slopes. And if you remember, perpendicular lines, we did this several units ago. We said perpendicular lines, their slopes are opposite reciprocals. Do you remember that? One was positive, one was negative, and you had to flip it. Both things had to happen. So let's talk for a moment. We already found these slopes, right? We already said the slope of side EF is negative 3/4. We already said that. We already established that. And we also already said for FG, we said that the slope of FG is 4/3. Check it out. One's negative, one's positive, and they're reciprocals. This one's 3/4, this one's 4/3. Oh my gosh, guys, they're perpendicular. But we had those slopes running around for all the others, right? Same thing. GH was negative 3/4, HE was positive 4/3. So GH and HE are also perpendicular. Ooh, sorry, my pen went a little crazy there. It's all right, we'll fix it. So these guys are also perpendicular, right? But that means these guys are perpendicular, those guys are perpendicular. Oh, check it out. Oh my gosh. So yeah, sure enough, guys, since the slopes are opposite reciprocals, the sides are perpendicular to each other. Therefore, our quadrilateral has 4 right angles, which means it's a rectangle. Yay. So quadrilateral EFGH is a rectangle. Yay for us. Now, slopes are not new for us. We've done slopes before, right? We know parallel lines have the same slope. We know perpendicular lines, their slopes are opposite reciprocals. It's been a while, but we have done that before. So this isn't really new. We haven't quite done anything new yet. But remember how the first problem we wanted to know if it was a square? We're missing some information, right? What information do you need to classify quadrilateral EFGH as a square? Hit pause, write it down, hit play to keep talking. So in order to be a square, we said we had to have 4 right angles, which we have. That was cool. We got that down. But we also said we need to know that the sides are congruent, right? So that's the other thing we need to know. We need to know whether the side lengths are congruent. This is rough because on that very first problem, it was easy to tell if they were congruent because we could just count, right? We literally just like counted little spots on the graph. That doesn't work very well here because of that slant, right? It was one thing when they were straight across, when they were horizontal, or when they're straight up and down, and they were vertical. That was easy to count. That doesn't work here because of that slant. I can't like count consistently. So we're going to do a little experiment here, and I'm going to show you how you can find the distance between these 2 points. Are you ready? That's pretty cool. It has to do with the Pythagorean theorem. And if you remember, we used the Pythagorean theorem at the very, very start of class in our warm-up today. So if you remember the Pythagorean theorem, do you remember it? A squared plus b squared equals c squared. And remember that c is always your hypotenuse, and it's always your longest side, right? All that good stuff. So what we're going to do is we're going to create a right triangle to help us find the length of the side. So on this quadrilateral EFGH, you're going to draw a right triangle, which we're going to call EFR. We're going to put some point out here in order to make EF a hypotenuse. So you're going to need to put some point out here off the side of EF to make a nice right triangle. You're going to need to go straight across, straight up, and name that point where they meet R. And then use the Pythagorean theorem to find the length of your hypotenuse, also known as EF. Go ahead and hit pause, work this out, and then hit play when you're ready to check your work. So the first thing is we got to draw that triangle, right? So I'm going to just come straight across. I'm just going to draw straight across, make a nice horizontal line, and then straight down to F to make a nice vertical line. Because we know horizontal and vertical lines will give us that right angle. So we're just gonna drop it. And we said we're gonna call this new point R, right? So we're gonna call that new point R. There it is. There it is. And we said we're gonna use Pythagorean theorem to find this guy, but that means I need these other sides, right? And that's actually easy to find. We did this earlier, right? We can count 1, 2, 3, 4. It looks like that side, ER, is 4. And then if we count this side, 1, 2, 3, nice and straight, the other side is 3. So I know that ER is 4. I know that FR is 3. So let's go ahead and plug in for A and B on our Pythagorean theorem in order to figure out what that third side is, what that hypotenuse is. So instead of A squared, we'll do 4 squared, and instead of B squared, we'll do 3 squared. Still equals C squared. We don't know what C is yet. But this is pretty easy to work out. And of course, calculator also useful. So 4 squared is 16. 3 squared is 9. All right. 16 plus 9 is 25. And remember, we talked about this earlier in our warm-up. You undo a square with a square root. So we're going to do the square root of both sides. The square and the square root cancel just to give us C. And of course, you know what the square root of 25 is. What times itself would give you 25? 5 would. Of course, your calculator can work out the square root for you as well. So it looks like the length of EF is 5. Yeah, look at us. We're magical and amazing, right? Right. So we just figured out the length of that side. And if we could do that for the other sides, we would be able to know whether or not this was a square. So what you've done something pretty magical here. And I don't know if you fully realize the magic you've just done. You use the Pythagorean theorem to calculate the distance between 2 points on the coordinate plane, right? The distance between E and F. Now you use the Pythagorean theorem to do it, but we can write that Pythagorean theorem a little bit differently. And that method can be written as the distance formula. Note how it's bolded. Note how this is one of your key words. This is important. The distance formula states that if you've got some point x sub 1, y sub 1, so you got an x coordinate and a y coordinate, and you have some other point, x sub 2, y sub 2. So you just have 2 points, x coordinate, y coordinate, x coordinate, y coordinate. So if these are 2 points on the coordinate plane, then the distance d between them is calculated using this formula. Do I have a highlight feature? I do. I'm going to highlight it. This guy, super important. You might want to highlight it in your book or circle it or something. This is super important and so useful. So yeah, you're going to subtract your x coordinates, square them, subtract your y coordinates, square them, and then add them together and do the square root, and you can find the distance. We actually did do this. We actually did do this on the last problem. We didn't do the subtraction part, right? We just counted to figure out how far down, and we counted to figure out how far over, right? So this is basically what we're doing here. We're counting to figure out how far over, but we're subtracting our x coordinates to help us do that. And we're counting to figure out how far down, but we're subtracting our y coordinates to do that instead. So instead of counting on a graph, you can just subtract the x coordinates to figure out that horizontal distance, and you can subtract your y coordinates to figure out that vertical distance. And then it's the Pythagorean theorem. Square them, add them, and then do the square root. This is the distance formula. It is magical. It is amazing. So the question I have for you, just to start us thinking about this distance formula, when you use the distance formula, does it matter which point you identify as your first point and which point you identify as your second point? Explain. Go ahead and hit pause, jot down your thoughts on that, and then hit play to keep the discussion going. So I noticed something here, guys. I noticed the squares. When you square something, it's always positive, isn't it? Right? Because when you square something, you're multiplying it by itself. Like if I do 4 times 4 squared is 4 times 4, which is 16. But even if it were a negative 4, if I square a negative 4 times negative 4 still gives me a positive 16, right? Negative times a negative. So those squares kill off any negative issues that might show up, which means this is a huge advantage for us. It means it doesn't matter which point is first and which point is second. It doesn't matter. So once you square those differences, the values are going to be the same. So the order doesn't matter. Just make sure you subtract your x's and you subtract your y's. And it really doesn't matter which one's first and which one's second. That's kind of magical and amazing. Sorry, it brings me joy. We don't often get to tell you that, right? We're all like, order matters. Not this time. So. I want you to decide whether or not this can be classified as a square. Can quadrilateral EFGH be classified as a square? We already know it has 4 right angles, but now you're going to need to find those sides. Use the distance formula. Now we're going to need to find those sides to see if it's a square. So go ahead, hit pause, see if you can do some distance formula to find those other 3 sides that we haven't found yet, and then hit play when you're ready to check your work. All right, guys. So I'm just making note of a few things here. Ooh, I need my pen back. I'm going to make note of a few things here. First of all, we already know we have 4 right angles, right? On question 3, we already said, hey, we have 4 right angles. We looked at the slopes. We already did that. We also already know that side EF is 5, right? I already know that side is 5. So we just need to show that the other 3 sides are also 5. So we're going to use the distance formula to help us do that. Let's start by finding FG. We're going to find this side right here. So real quick, the coordinates for F, what is that? I went right 6 and I didn't go up or down, so I guess that's 6, 0. For G, I went right 3 and then I went down 4, so that's a negative 4. So let's go ahead and let's use the distance formula to help us do this. So for FG, we said, so I've got my distance formula. I'm going to do a big square root. And we said we're going to subtract our x's, square it, subtract our y's, and square it. And then we'll add them together. So let's see. So we got to subtract. So my x-coordinates, well, his x-coordinate is 6. His x-coordinate is 3. So 6 minus 3. And then y-coordinates, right? His y-coordinate is 0. His y-coordinate is a -4. Ooh, watch out for that. Okay, let's work this out. It's not that bad. 6 minus 3 is 3. So that's 3 squared. 0, ooh, double negative becomes a positive. 0 plus 4 means that I get 4 squared. So we've simplified this and this. 3 squared is, of course, 9. Plus 4 squared, which is 16. And 9 plus 16 is 25. Oh, and the square root of 25 is 5. Yay! So that side is 5. Excellent. Let's now find the next side. Let's go ahead and find HG. We already have a coordinate for G. Let me write down the coordinates for H. It looks like we went left 1, and then we went down 1. Okay, so let's do this again. Let's do GH. Oopsie, sorry. GH. My pen. Always causing trouble. So we know there's a big square root. We know we're going to subtract our x-coordinates and square them. We know we're going to subtract our y-coordinates and square them. So fine. X-coordinates. Again, doesn't matter which one is first. It really, really doesn't. So I'm just going to use this guy. I'm going to do -1 minus his x-coordinate, which is 3. And then we'll do the y-coordinates. -1 is the y-coordinate for H, and -4 is the y-coordinate for G. And then we're going to clean up a bit. -1 and a -3 gives me a -4, which is going to get squared in a minute. Negative, negative, double negative there. That becomes a positive. So -1 plus 4 is actually a +3, which will also get squared. All right, -4 squared, -4 times -4, +16. 3 squared, 3 times 3 is 9. And of course, 16 plus 9 is 25. Ooh, last but not least, square root of 25 is 5. Don't forget the square root. People seem to forget the square roots. Don't forget the square root. Oh, that's great, right? Because that means that side is also 5. Hooray, just like we wanted. So one more side. If that last side matches, we're in. So let's check side HE. We're so close. We're so close. Sorry, my pen's going weird. So we're going to do a big square root. Subtract our x's, square them, plus the difference of our y's squared. All right. All right. Oh, I need a point here for E. So it looks like we went right 2 and we went up 3. All right. All right. So let's do this thing. X coordinates and X coordinates. So 2 minus a -1. And then 3 for the Y coordinate minus this Y coordinate, which is also a -1. Ooh, sorry, I got crammed in there. Let's clean it up. Double negative becomes a positive. 2 plus 1 is 3. Don't forget my big square root. Again, double negative becomes a positive. 3 plus 1 is 4. And let's do our squares. 3 squared is 9. 4 squared is 16. And of course, 9 plus 16. Oh, you see where this is going. It's 25. And the square root of 25 is 5. Look at that. We have 4 congruent angles and 4 congruent sides. Guys, this is a square. Here, I'm going to erase this so you can see like my prettier writing. It'll look a little better, you know. Yeah, so it looks like all of our sides are 5. Every single one of them. Yeah. Which means there's 4 congruent sides, which means quadrilateral EFGH is, in fact, a square. 4 congruent sides, 4 right angles. Boom, we got this. All right, guys, let's simplify it a little bit. I feel like maybe we need to practice working with that distance formula. Were you having some trouble with the negatives, a few of the things in there? Because I think you probably were. So let's go ahead and let's practice a little bit, shall we? Let's go ahead and let's do some distance formula. Let's go over to question number 8. On question number 8, you actually have several of these. I could only fit so much onto my paper, guys. I only have so much space. So you've got 3 of these here on your page. Use the distance formula. I would like you to use the distance formula to calculate the distance between each pair of points. Use a calculator. You're going to find that not all of these are going to work out as pretty and perfect as our square root of 25, where we got 5 exactly. So use a calculator to help you do your square roots so that you can round your answer to the nearest tenth. Make sure you show your work. Go ahead and hit pause, dive in, and then hit play when you're ready to check your work. All right, let's do this. I'm going to do this. So I'm going to use my distance formula. And I can see that these are my x coordinates, 1 and 3. So I'm going to do 1 minus 3 in here. And then these are my y coordinates, 2 and 7. So I'm going to do 2 minus 7 over there. And now this is just a matter of cleaning this mess up. So let's see, 1 minus 3, that's a negative 2. 2 minus 7 is a negative 5. And then we'll square it. So negative 2 squared is 4. Negative 5 squared is 25. 4 plus 5 is 29. And at this point, I'm grabbing the calculator. I don't know what the square root of 29 is. I have no idea. Ooh, helps if I hit the right buttons. So I'm going to find the square root of 29. And it turns out I get about, if I round to the nearest tenth, 1 digit behind the decimal, I get about 5.4. That's not very pretty. So I'm going to erase it, and we'll show you the pretty version. Yay. Look at B. Let's see how you did with B. Let's check it out. So x coordinates and y coordinates, right? The x's go together. So negative 6 minus 2. The y's go together. So 4 minus a negative 8. Watch out for the double negative. Watch out for the double negative. Ooh, and so the double negative does become a plus sign. So watch out for that. Negative 6 minus 2 is a negative 8. So that's going to get squared. Plus 4, now it's 4 plus 8 because our double negative became a positive. 4 plus 8 gives me 12, and that's going to get squared. 8 squared, negative 8 squared becomes a positive 64, and 12 squared is 144. And I need my calculator here. 64 plus 144, that gives me 208. And I definitely need a calculator because I don't know what the square root of 208 is, but my calculator does. And so it looks like if I round to the nearest tenth, I get 14.4. Yay! Again, I'll show you the pretty version. There's the pretty version. Let's talk about this last one then, part C. So again, subtract the x coordinates. So negative 5 minus a negative 6. Subtract your y coordinates, so 2 minus 10. Set that up. There we go. All set up and ready to go. Now we got to clean this up. Well, the double negative here becomes a positive. So negative 5 plus 6 is actually a 1. 2 minus 10 is a negative 8. And then it's not so bad. 1 squared is 1. Negative 8 squared is a positive 64. And of course, 1 plus 64 is 65. And last but not least, I'm going to grab my calculator to help me out with this one because also not a perfect square. So I get, again, if I round to the nearest tenth, I get about 8.1. Again, I'll show you the pretty version. See, isn't it pretty? It's so pretty. So pretty. Beautiful. We're almost done. We're actually really close. We're actually really close to being done. This is some great work, guys. Last but not least, we're asked to calculate the distance between the points -1, -2, and -3, -7. And you may notice that there's some similarities here, right? This problem is kind of similar to the part A on that last one we just did, if you need to go back. It's very similar to part A, only now, instead of +1, +2, and +3, +4, It's now -1, -2, and -3, -4. So Carlos says that the solution must be the negative of our solution in part A. So part A, we got 5.4. And Carlos says, hey, since these points are negative, the distance must be a -5.4. But Mandy disagrees and says that the solution will be the same as the solution in part A. So who's correct? Explain your reasoning and also find the correct solution, all right? Go ahead and hit pause, find the correct solution, and explain who's right and why. And then hit play when you're ready to keep the discussion going. So I actually set it up first and worked it out first. So I'm going to subtract my x coordinates, -1 and -3. And then I'll subtract my y coordinates, -2 minus a -7. And so I started off by setting it up, and I had so much going on here. So the double negative becomes a positive. -1 plus 3 is 2 squared. Oh, my big square root. Don't forget my big square root. Sorry, it got messy. Also a double negative here, so -2 plus 7 gives us a 5 squared. Interesting. 2 squared is, of course, 4. 5 squared is 25. Hey, I'm seeing some familiar numbers here. So I get the square root of 29, which we said was about 5.4. So check it out. Mandy was right. I'm going to erase this so you can see my prettier version. So Mandy was correct. And remember what we said earlier, because we're squaring those differences, the solution's always going to be positive. And that makes sense. We're talking about a distance. Distances are always positive. There's no such thing as a negative distance. Somebody asks how far away you live. You don't say, I live about -5.4 miles away. Nobody says that. Nobody says that. So Mandy is correct. Because we are squaring the differences, the solution will be positive. As always, guys, I hope you found this helpful and I hope you found this useful. If you have questions or concerns, feel free to chat with me during class, email me, or of course, come see me during office hours. And I'll see you soon. Bye.